Okay, so for this first free response, maybe, the first thing they asked was to find the area. Johnny? And so we were given a lot, in second period, there's a lot of discussion about what should be the bounds, but they kind of gave you the bounds, right? So the area, using the bounds that we have, would be 1/2 the integral from 0 to pi of the function 1 plus 2 cosine 2 theta. Now, oh, that's the wrong one. Theta plus sine theta, Sorry, looked at the wrong one. Theta plus sine 2 theta. It's important to use the right function. Okay. Once we have that, we can just put that into the calculator, and I got 4.3823. Okay. On the AP exam, to save time, guys, don't talk while I'm talking, because one, it's irritating, and two, it's irritating. One of the things you can do on the AP exam to save time, you can do this, integral from 0 to pi, and just write r squared, because r was defined for you. So you can do that on the AP exam. You cannot write calculator notation, but you can write this. So how many points do you think this was worth? I would say probably 2. 1 point for the answer, and 1 point for the integral and the bounds. I don't know for sure, but that would be my guess. Okay? B, find the angle that corresponds. Now, there are a lot of questions about this, but we're asking you to find the angle that corresponds to x equals -2. So if we're looking for x is equal to -2, we have to write this in rectangular form. So I have to remember that x is equal to what? R cosine theta. And since r is equal to theta plus sine 2 theta, then times cosine theta, and we want that to equal to -2. Now, a lot of people have problems with this in second period because they couldn't understand how I could just, in rectangular form in my calculator, in function form in my calculator, I can just put this in the calculator? Yes? I can just put this in the calculator? As x in function form. So it would be x plus sine 2x cosine x. I'd put that in y1. In y2, I'd put -2, and I'd find my point of intersection. When you graph that, you could possibly get several points of intersection. How do you narrow it down to just the one that you want? Jake? You look at the bounds. So in your calculator, your x min would be 0, your x max would be pi, because you only care what's happening in there. Okay? And according to what I got x is equal to, actually theta would be equal to 2.78606. All right, if you need help doing that on your calculator, I will show you when I'm finished with this. Any questions on B?
So you just plug it into the function
Y1 and Y2 in function mode, yes, and find the intersection. Change your window, yes. Because at this point, I'm just solving this equation. I'm not graphing it in polar mode. I don't really care what it looks like. I am just solving this equation. So I can solve that equation in function mode. I don't know what it looks like in polar mode. I don't know how to do it in polar mode. I'm sure there's a way. It just... All right, C. They tell you that dr d theta is negative. What does this fact say about r? So they tell you it's negative. So that means that r is decreasing. Because dr d theta is negative, r is decreasing And because its slope is negative, that means it's moving toward the origin, or toward the pole. Okay? Last one. Now, at this one I would think would be worth 2 points as well, be my guess. I think you probably got 1 point for writing it as x equals, and 1 point for your solution. This could possibly worth 1 point or 2. So how many have we got? 2, 4, 5. I would probably say it's 2 points. 1 point for each part of the answer. Now, D is where most of your points are going to come from because that's probably the most difficult part of this question. They want to know, find the value of theta that corresponds to the point of the curve in the first quadrant with greatest distance from the origin. Okay, that statement tells you a lot of things. If we're talking about greatest distance, what does that remind you of? Maximum. Not just the maximum, but what type of maximum? Absolute maximum. So if we're looking for an absolute, if we're looking for any type of max or min, how do we find it? Set the derivative equal to 0. So since they already gave us the derivative, we would set this derivative equal to 0. So the derivative was 1 plus 2 cosine 2 theta. And we get theta, we get cosine 2 theta is equal to negative 1/2. When is cosine negative 1/2? 2 pi over 3 and 4 pi over 3? Okay? So that means that 2 theta is equal to 2 pi over 3, 4 pi over 3. That means theta is equal to pi over 3 and 2 pi over 3. One of those is outside of my bounds. Which one? That's outside of my bounds, so I'll have to look at pi over 3. So because we're looking for an absolute, that means we have to do what? Check our endpoints. What are our endpoints? 0 and pi.
Yeah, it's probably because of the question.
Yeah.
Oh, yeah, you just have to 2 times that, right? No, just pi over 2, or the part was that.
Then we can use our handy-dandy calculator. As long as you're in radian modes, it really doesn't matter how you would do this. So you would do R, which they gave us the value. They gave us R at the top and set it theta equal to 0, and calculate your values. For some reason, I don't know why I didn't write that to 3 decimal places, but you know you need to write it to 3 decimal places. So which one is the greatest? Pi over 3. So the greatest occurs at pi over 3, and the greatest value is 1.93. To justify that, you could say, you know, it's a, excuse me, using the the table of values, we see that at pi over 3, it's the greatest, it's the maximum, comparing it to endpoint. Okie dokie? Yes? All righty, I want you to do the next free response question.